Have you ever wondered how artificial intelligence could revolutionize the world of surface mount technology equipment? Artificial intelligence, or AI, is not a concept confined to the realms of science fiction anymore. It is a real, tangible force that is transforming various industries across the globe. From automating routine tasks to predicting future trends, AI is pushing the boundaries of what's possible. One industry that stands to gain significantly from this AI revolution is the world of surface mount technology, or SMT. SMT equipment is integral to the manufacture of electronic devices, and its efficiency and reliability are paramount. Enter AI. With its ability to learn, adapt, and make decisions, AI can play a significant role in enhancing these aspects of SMT equipment. It can lead to improvements in diagnostics, maintenance, and uptime, fundamentally changing how we approach manufacturing. As we delve deeper into this topic, you will discover how AI is not just a buzzword, but a game changer for SMT equipment. Picture this, an SMT machine that can diagnose its own issues. Sounds like science fiction, right? Well, not anymore. Welcome to the era of self-diagnostics in surface mount technology, or SMT equipment. This isn't just some fancy, high-tech jargon. It's a revolutionary concept that's changing the game for electronics manufacturing. Self-diagnostic capabilities mean that SMT machines can now identify and report issues on their own, without the need for constant human supervision. Think of it like a built-in mechanic, tirelessly working around the clock. This is where artificial intelligence comes into play. By leveraging AI, these machines are able to learn from past behaviors, detect anomalies, and take corrective actions, all in real time. The result? A significant reduction in downtime and a boost in productivity. Imagine the possibilities when your SMT equipment practically takes care of itself. With AI-powered self-diagnostics, SMT equipment becomes more reliable, reducing the chances of unexpected breakdowns. Now,